Okay, so in this next set of questions, we're going to find points of discontinuity of piecewise functions. Now, the major assumption is that all the piecewise functions are comprised of just regular algebraic functions. There's no roots in there and things like that. While that is possible in reality, that's going to make the questions a bit more complicated, and I may post videos about those later on, but these are just basic piecewise functions which are typical in your first year calculus courses. Now, anytime you're looking at a piecewise function, you have to look at the points where the function changes. So this one, it's x equals to 1. So we're going to do our evaluation at x equals 1. Now, all you want to do is make sure that the left side and the right side are the same. So I'm going to try x plus 1 equals 5 minus x, and then I'm going to sub in my common point of 1. So 1 plus 1 equals to 5 minus 1, 2 equals to 4. That's not true, which means that the point is not, or the function is not continuous. It's basically discontinuous at x equals 1, but the function is continuous everywhere else. Let's try the same thing for question number 2. So our common point here is at x equals 2. So x squared equals 2x. I'm going to sub in my point of 2. So 2 squared equals to 2 times 2. 4 equals to 4. That is true, which means that the function is continuous everywhere. Let's take a look at the next one, which again has a common point of 0, but it has 3 different functions. Again, all 3 have to match in order for the function to be continuous. So at x equals 0, I'm going to do x equals to 0 equals to x squared. Then my point is 0, so 0 equals to 0 equals 0 squared is just 0, which means that this function is continuous everywhere. Remember, if it's a common point for all 3, all of them have to match. Let's take a look at this next one, which again has 3 different functions, and it's at x equals to 1 this time. So x equals x plus 1 equals x squared. If I sub in 1 over here, that's 1. 1 plus 1 is 2, and 1 squared is 1. Since all 3 are not the same, the function is discontinuous at x equals to 1. Still have a couple more examples on our sheet. So now we note for these functions that they have 2 different common points. The first 2 functions are common at x equals 2, and the second 2 functions are common at x equals 4. So I'm going to start this one at x equals to 2, and I know the first 2 functions are x squared equals 2x. I'm going to sub in my common point of 2, so 2 squared equals to 2 times 2, so 4 equals to 4, which means that the function is continuous at x equals 2. But now I'm going to try it at x equals 4. So at x equals to 4, I'm going to match these 2 functions, so 2x equals x plus 1. 2 times 4 is 8. 4 plus 1 is 5. That's not true, which means that the function is discontinuous at x equals 4. But the function is continuous everywhere else, including x equals 2. Same idea in this one. I have 2 different points where I have to test. I'm going to test first at x equals 0. The first 2 functions, x plus 3 equals to 3x. 0 plus 3 equals to 3. 3 times 0 equals to 0. That's not true, which means that the function is discontinuous at 0. Let's test the second point, x equals 2. So 3x equals x squared. I make the next 2 functions equal. 3 times 2 is 6. 2 squared is 4. That's not true again, which means that the function is discontinuous at both points. So discontinuous at x equals to 0 and x equals 2. The function is continuous everywhere else, but discontinuous at those 2 points. And finally, let's test this last one. Again, 2 different points which I have to test. I'm going to test -1 first. So -1 minus 3 is -4, and -1 times 4 is -4. So the function is continuous at x equals to 1. Let's test the next one, x equals to 4. So I have 4x equals x squared. 4 times 4 is 16. 4 squared is also 16.